Good morning, everyone. Another Advent of Code video. I already started loading input as yesterday, so we can save a bit of time. So first it starts with the assessment we got, with the puzzle assignment we got. We have a map, right? And this is basically a height map where A is the lowest height, Z is the highest possible height, S is always A, so S is always 0, E is always Z. So this is basically like a height map. Now, S determines starting position of our puzzle, E is our goal, and what we have here, it is a labyrinth. Why labyrinth? Because we can only move from position we are into the position which is at most one higher. And I hope that I understand it correctly. I can go as much lower as I want to. I don't know if it matters, but this is what I assume in my implementation. So I can go like S to A because it's the same height here, and this is basically the path which is shown. How you can reach from the start to the end, B, then C, then this C, right? And what do you want to find is how many steps do you need to reach E. And this is well-known problem. There are two ways we can solve this. One is BFS, second is A star. And because our input is not so small, and yeah, I think BFS would be fast enough for this, and I don't want to bother implementing A star, which is very simple to implement, but BFS is even simpler. So I think I will go with BFS. Theoretically, BFS can be, I think, very slow, because I may visit every node many times, but I don't even know how many times, so I don't know how complicated could it be, but how complex could it be, but it doesn't matter. Oh, my son again joins the recording. Okay, so let's start implementing BFS, and the easiest way to implement BFS, or to implement BFS, sorry, I was talking to my wife, is to have the second, oh sorry, let's go through the input loading I have. So it is, first of all, I don't know why before I forget about this pickable function, which was useful once. I have my lines, but I make it pickable so I can look at the first element of the iterator, do not consuming it. And it is very useful because now I can just determine the width of my map by looking at the top, on the top line of the input, and its length is bit of my map, right? Then map is just flattened vector, so I keep it in one row. So I would address it with, you know, this arithmetic with x plus with that times y, but it won't matter at all in the implementation. I ignore my invalid lines, and then I flat map them, but I convert them to bytes from characters because I want my heights. And for easier reading, I would even scale them in a second, because when I collect them, I look for my start position, I look for my end position, just by looking for position in the vector of the S and E. And then when I have my start and end position, I could do into iter, map and collect, but this is why I called also into bytes here instead of going with characters here. I am mapping from bytes which are U8 to different bytes, so I do not need to reallocate my vector. This is just slight maybe not the nicest, but optimization, let's say, right? So I have my scaling started, so it's 0 and it's the biggest possible value, which is z scaled by by a, and anything else is just h lowered by a. So a goes to 0 and then increasing. I return my map, and my map is map with start and simple enough. And I implemented one function, and this is basically part of the solution. So I want to go through this, which is nightboss. And this function will take my position, like this is, I think it's f a, it is 8, a is 8, 9, 10, 11. So I pass here position of a, and it should give me back every places where I can go. Not only every nightboss, but every nightboss I can go. And I use some tricks here. So first of all, I create some array of some options. And those options would be, if there is a position in this, if there is an index, oh, my kids are fighting. If there is something in this direction, then there is some, otherwise it's known. So for example, for Q, this would be known, and here I have some position, right? So it should be done this way. And if we go one by one, I do this by calculating the position of potential node, and then I filter it out if I decide there is nothing. I find this trick to be sometimes more readable than going with if else for every line. It is one liner which you can use too. I am not sure if it is the nicest thing, but you can sometimes see this trick. So first I wrapping sub the surface. And why wrapping sub and not minus? Because I want this not to crash in debug mode, and those width and position are unsigned. If it would go negative, it would basically panic on debug mode. On release it would pass, and it would be on release it would be exactly the same thing like as wrapping sub, right? But anyway, I just go with this wrapping, so it would just wrap around. But if my position is bigger than the width, so it is lower by the width, I would filter out or equal the width. Should probably be equal. No, it has to be bigger to be accepted, right? Width is 8. No, it can be equal. So I already screwed it up. So how does it work? This S is less than 8. Position is 0, right? And because of that, I know that if I do how is it in English? If I not substitute, sorry, I'm disturbing. If I do my 0 my 0 minus 8, I would go below 0. And because of that, I just do filter it out, because I'm sure that this would be wrapped value. Another thing I could also do, by the way, position is bigger than the maximum I expect, but doesn't matter. Here I can just add, because it would never wrap, but I filter if this value is went outside of the range of my LAN. And basically I could do the same here, because it is wrapped, it would go behind, not below, above my length for sure. Then the same thing, wrapping sub minus. So basically I'm here. Wrapping is only important for the first value, but I need to filter it if the position modulo my width. If position modulo my width is 0, then I'm sure I'm on this one, right? And for those positions, I don't actually want to have anything on my left side. So then I filter it out, position +1, but I do it only if my result ends up going to be different than this. So the same, if after going right I am ending up on this position, I want to filter this thing out. And this way I have some optional positions which I into eta to flatten. So funny thing is that options can be treated as iterators of 0 for values. So I can flatten it as they will be iterators, and I would just collect my values of sums into some iterator, which then I filter. And this is the most important filter in the solution. And how it works, it has either my destination, map P is what I have in the destination, in the position, is lower than my position I'm going from. Yeah, then it's okay, I can go lower always. Or if my difference is 1, right? So if difference of the positions is 1, then I also can go one step up. And you could argue that I could just go like map minus map P minus map pos is lower or equal than 1, but it won't work because it is unsigned, so it will trap. I would need to convert it to signed, which, yeah, I mean, technically this is also a way, maybe even easier to reason about. So maybe let's leave it this way. Right, so this is exactly the same thing, except here I just check like manually if it would go negative. And then I collect those neighbors to the vector usize. We can verify if it works like quickly. I already did it before, but we could just try to print out all the neighbors. Let's say start is very boring there, but we can go with 11, 19 and 12. 11 is, it's 8, 9, 11. This is 11, this is C. Right. No, it's not. 8, 9, 10. This R is 11. Now it makes more sense. So okay, I think something went a bit wrong. Let me copy it, so I would paste it in a second, and let's go back to my previous implementation. I might screw something up. Paste this. Yeah, this filtering was screwed up. I don't want to think about why. Probably some typo. So yeah, for this R, I can go to 3, which is Q. I can go down way. I can go to C. This is left, so this is 10, and 19 is this S. I cannot go to Y because it's too high. I am not sure if I can go down because, but it is at most 1 higher. Can be much lower than the elevation of Q square. So yeah, it seems like this is correct. So now how do we approach the BFS? The easy way, we have another vector on the side, which would be mode. Oh, my kids are happy. There's snow outside. So that might be a reason. We would have distances. This is the vector of distances. And it would be used as max here, so it is the highest possible distance from the start. This would be distances. How far is this field from the start? This square we are going to. And its length would be the length of our whole array. We'll leave 0 here. And now how we do that, we need another vector. Let's move let move q. It is q. It could be vector q. We would use vector for simplicity. And q are the q are fields to be calculated. So the distances to be analyzed next. And we know for sure that distances of start is 0, because distance from start to start is 0. So now what we do this while q this is very algorithmic and very not functional thing. So while let samples is, so what we do, it might, we'll see it in a second if it's okay, or maybe not. I will try to write it myself. So while there is something on my queue, then the first thing I do is, okay, detected it. I need to take my neighbors, which are places I can go to. And for every neighbor, if its distance n, and now no, and this is wrong. It's not usage max. If distance n is bigger than distance pos where I am plus 1. So I know my distance to the place where I am, and I know that I can achieve the other distance by moving one square. So I know that the distance to the next square is at most position plus 1. Yeah, maybe there is another path there, but I don't need, and maybe I even achieved it earlier, but I don't need to care about this other path. And I am pretty sure actually that in BFS I always achieve the place with the closest path, so it is actually ORM probably. I was wrong at the very beginning because I really don't implement those algorithms on daily basis. I just create this distance plus 1. I think that what I said, that the node could be visited multiple times, it is true for a star, so it has pessimistic complexity, but it has very good modulated one. Anyway, then I add the node I just visited to the queue, so it would be analyzed next, and it would, like, you know, it would cover the whole thing. But I don't even need to go through entire map, because I am pretty sure that what I told right now is true, and if I reach some field, I reached it in the closest possible path because of how every time I add the node it has to, you know, grow. I will never analyze nodes being the distance of 2 unless I finish all 1 distances. So I am pretty sure that now in this thing I can actually do if n is map and I can return at its distance, and I can do it even before. Yeah, I don't know, this is the best place. If I reached end here, I think that I visited for the first time. I can always overrate it. Yeah, I do it because for sure in BFS I could visit the node from 2 places of the same distances. Because yeah, how it works, I would if I have like think like let's say, first I start with only this hash in the queue, right? Then I analyze those nodes. So maybe do it different. So this is starting point, this is 0, then I make those 1, and both of those could be visited from 2 positions, assuming no, there is no barrier. But yeah, that's why I want to figure out if it was not already visited once. So I actually could probably leave here the max. Doesn't matter. Doesn't matter, that's good enough. If I reached my end, then I can return the distance, because the only thing they ask me for is distance, right? Yeah. If I am here, then it means I never reached, so I could return 0. Because yeah, some value anyway. Let's check my tests. 31. Seems to be proper answer, right? My answer is too high. That's surprising. That's surprising. Let's check if I remove this guy. And then I would just return here distance of map. And the thing is that if I was wrong and yeah, I was actually wrong, and I don't want to exactly analyze the input, but what happened, it apparently it may be because this graph we are working on is directed. So sometimes we can go one way, but we cannot go back the other way, right? And that may be a reason for what happens. But the thing is that it may be a case that I visit my node more than one time with the lower, like shorter path later for some reason. But it doesn't matter, this works, and this works because now I am making sure that there is no optimization possibilities anywhere on the map here, and then I return the end distance, and yeah, this should work this time. Did I talk for a minute about that? Yeah. So yeah, so BFS is actually not linear. I really don't remember its complexity. Doesn't matter. Also, to maximize it, the try should start. Mm. Be direct, taking the fewest steps. Okay, so this is even better that we choose BFS over A star, because A star is not the best for looking for paths from multiple starts or to multiple directions, because this is basically the same, I think. Maybe there would be some modifications actually to reverse that. But anyway, for our BFS, this is very trivial because we do not now count the distance from my start position, but from the closest A position. And the difference here is that I can just, I just need to set up it differently a bit. So, and now it would definitely can visit the same place multiple times. So I would go this way. So net mode Q is distance. I would do a bit dirty, but doesn't matter. I go itermute, so I would iterate it, but I would be able also to mutate it in place. I would enumerate them because I would need to have access to index, and I would map them, filter map them, filter them only. I need to filter them. If D is 0, or even better, I can just build distance differently. Distance, I can do that without dirty tricks. It's map dot map dot. I would just iterate. I would map it. Here I am basing on what is height. It may be 0, in which case our distance to any square of height 0 is 0. Our distance to any square of distance being more than 0 is basically max. So this is how I prepare our distances. And then I need to prepare Q a bit differently. So it's distance. I would just iterate over them. I do not need to mutate them anymore. I need to enumerate, filter, those. I want to filter out those squares which has distance of 0, which are our potential starting spots. And then I map it to figure out the indices and I collect them. And also, this is our starting Q. And everything else is exactly the same. I just go through all the squares, updating things. Let me check test in. 29 steps is proper answer. Let's use my in. Okay, you've seen that it is a bit slow right now. Yeah, I think I could use a star with reversing, so going from end to start to make it a bit faster, but if you want to, you can do it yourself. This was one start, and thank you for watching. See ya tomorrow. Bye.